Okay, and then the last question. Oh no, wrong one. Sorry. So we've got the last question, which is question 7. We've now got a force. Prove that the possible resultant force to act in the direction of k. So if we're going to take this as though it is going to move in the direction of k. So if it was to move in the direction of k, we're expecting no movement, and the resultant force has to be in this direction. So we can call the resultant force, let's just go with r. Okay, so it'd be 0, 0, r, some sort of movement. That's what we'd expect for the resultant force. Okay, so the resultant force would end up being 0, 0, r. Now, in order to get that, it would mean that I'm just going to call this A and this B. So we end up with 3 minus 2 and 1. And we add that to our B1, 1, 3. It's just easier for me to write A and B with this pen. And that is going to have to equal 0, 0, r. Now this ends up creating an equation, so we end up with 3a plus b equals 0. We end up with minus 2a plus b equals 0. And we end up with a plus 3b equals r, the resultant force. So if we now get it's just to both to be b equals, then we can say that b is equal to negative 3a, and we can say that b is equal to 2a. Combining these together, which means that minus 3a equals 2a, which means that a would have to equal 0 for this to be true. The only value for a that this works for is if we make it 0, which means that if this is 0, then we can sub this in to any of the equations, and you'll then see that that means that b must equal 0. So if a and b equals 0, if we put that into this equation, then we end up with 0 plus 0 equals r, which suggests that r is equal to 0, which means it's impossible for the resultant force to act in the direction of k.